All right, hey guys, I heard you had some questions about some of the exam, final, review, practice, test questions, all those words. Please ignore how short and ugly and boring my nails are, but I'm going to point to some stuff. So in this section, I printed out the whole thing, fill a little multiple choice / write your own answer. They're not going to be super long, detailed, write in your own answer. It's going to be like a number. But for the second page, some of these, they're a little bit weird, especially because some of the answers are very, very close together, especially for number 9. B, C, and D are all really, really similar. And again, this test is modeled after pretty much very, very, very close to what you're going to see on the actual final exam. So there will be sneaky questions like this where they're really, really similar. And so the key to that, and we'll see that in a second, is you cannot round anything further than you should until like the very last minute. But let's start with number 8. So converting between Cartesian or rectangular coordinates and polar coordinates is really saying, so in rectangular coordinates we say, okay, go out this far and then up or down this far. So 2, -1 says go to the right 2 and then go down 1, and that's how far you've traveled from the origin. Well, polar coordinates instead say, how far out do you go and then in what direction do you swing? So instead of an x and a y, they have a radius and an angle, r and theta. So what we really need to do is find this distance. So if this were on a circle, how far would that point be from the center? And what is the angle that it's rotating down to get to that point? So this is always 0, and we measure from there. You'll notice that these are some pretty ugly numbers, so we're probably in radians, not degrees. And some of them are going to be negative, some are positive. So a negative angle means we're going clockwise, positive means we're going counterclockwise. So we've got some factors to work with. You'll also notice all the radius values are the same, so we've got nothing to go on there. We can't really process of eliminate any of those, but it gives us a shortcut. We don't have to bother finding the radius. We know it's going to be that. Now we just need to find which of these angles it is, and for this, like with a lot of things that we do with rectangular coordinates, we're going to use the fact that the x distance and the y distance really form the legs of a right triangle. So if we went over 2 and down 1, really what we're looking for now is this angle, which in a right triangle we can find by taking tangent inverse of opposite over adjacent, so -1/2. And I am going to keep it as -1, even though if this were a real life physical triangle, we can't have negative distance. But in this case, it is going to help us figure out which one's positive and which one's negative. So grab a calculator, go to mode, make sure we are in radian mode, because we definitely want our answer in radians. You'd see pretty quickly that none of the answers work if you're in degree mode. Okay, so we want tangent inverse of -1/2. Oh, oops, I did minus. Oh my god, I'm so out of it. Tangent inverse of -1/2. Okay, -0.4636. Hey, that's option A. Alright, so, again, if you had done this in degree mode, hopefully you'd see pretty quickly that, that's absolutely not even close to any of those answers. Each of the incorrect answers are numbers that you might find along the way if you either plotted your rectangular point wrong, or if you forgot to make the 1 negative, or you switched the 1 and the 2, something like that. So converting between rectangular and polar is not too bad. Tangent inverse is going to be your friend. To go backwards, remember that you have r² equals x² plus y², and all that business that you use to convert between equations as well. Alright, 9, there are 2 different ways to do it. I actually need some more space, because I'm a big drawer, so I'm just going to draw a picture. Take up plenty of space. Alright, a force with a magnitude of 40 pounds. So I'm going to draw a little force diagram here. And a magnitude of 30 are applied to an object. So this will be our object. So maybe this is the 30-pound force and this is the 40-pound force. When we draw these as vectors, we're really just saying that the length of the vector is equal to the the force that's being applied. So we have one of length 30, one of length 40, and there's 45 degrees between them. Then it wants to know what is the magnitude of the resultant force. So the resultant force is what you get when you add two vectors together, and it's really saying, okay, if these two people or whatever are pushing this box, it's really going to end up going, this way, and with what force and in what direction is that being pushed. Except they don't need direction, we just want magnitude. So that's great, that's easy. So there's two ways we can do this again. One is with straight up just using vector addition properties and like the physics way to do it. And the other way is actually to lay these vectors head to tail and use the law of cosines. So let's start with what I think is the easier way, which is just to do vector addition. So let's just orient ourselves on an imaginary little coordinate plane. So I'm going to call this the vector 30, 0. I'm just going to choose that orientation just because it makes it easier. Now I need to write this one as a vector. It's obviously not going just straight over, but remember that we can write vectors with their x and y components as part of a right triangle. So if we have a right triangle with a hypotenuse of 40, then our x value is going to be, well, we know that cosine of 45 degrees would be x over 40. We know sine of 45 degrees would be y over 40. Cosine of 45 is the same either way as sine of 45, so our x and our y are going to be the same. So grab our calculator because we're lazy, because this is root 2 over 2, but I'm trying to get it as a decimal. Let's see, so we should probably go back into mode. Oh, we're already in degree mode. I switched it back, that's right. Okay, so cosine of 45 times 40, 28.2843. So I'm going to take that out to 4 decimal places, because that is where all of our answers are at, and because they're so close together, we just want to make sure we're going to get an accurate-ish answer. So that means sine is the same thing. All right, so our vector is going to be that. So now we just add these two vectors together, add their x components, add their y components. So our resultant force is the vector, let's see, 58.2843, 28.2843. Then all we need is the magnitude of that vector, which is really just the square root of the x component squared plus the y component squared. So the square root of 58.2843 squared plus 28.2843 squared. All right, so that's some boring calculator stuff. Let's have him do the work for us. All right, so I'm going to make sure I get all my good parentheses in there. All right, 58.2843 squared plus 28.2843 squared, 64.7847. So hopefully that matches one of our answers. Yay! Yeah, these are all really, especially these two, very, very close together. If you round too soon, they're going to try to get you. Let's look at the other way to do this, which is instead of just finding the resultant vector, using the sort of visual representation of vector addition. Say if you have these two vectors, really you can transplant this one up to represent their addition. So you're really looking at the vector that stretches from the first tail to the last head. And let's call that A. This is what we want to know. And let's call the angle across from it angle A. Let's see, this is 30, this is 40. We know that the angle between the two vectors, so this angle, but also this angle, was 45, which means that this angle, the supplement, is 135. So maybe you see where I'm going with this. Now we have a setup for the law of cosines, which says that little a squared equals little b squared plus little c squared minus 2 times b times c times cosine of angle A. So we have all the ingredients that we need for this, and we can just plug in the 40, the 30, and the 135 degrees, see what we get. So I'm going to go ahead and also in one step solve for A, which means I'm just going to take the square root of the other side, and I'm just going to write it out so I know that when I'm plugging it into the calculator I'm not making any mistakes. Cosine of 135. Alright, so I'm just going to put all this into the calculator. So obviously this depends on remembering the law of cosines, so it might not be that helpful of a method if that's not what you're about. But if it is, it can be faster in a way. So I'm going to make sure that I'm still in degree mode. Yep. Quit. There we go. Alright, here we go. Putting it all in, making sure everything goes where it's supposed to go. 40 squared plus 30 squared minus, I'm just going to do some parentheses, 2 times 40 times 30 times cosine of 135. And we get 64.7847, which is the same thing we got here. Oh my god. And it's the same thing that we got as our answer. So that's good. It all worked out. So especially when you're doing this, if you just put it all into the calculator in one go, you'll be a lot less likely to accidentally round something too soon and get an answer that's slightly off. So again, on the final exam, you know, they're just trying to be mean. They're going to put a question that you just have to make sure that you're not truncating or rounding anything, because the answers will be really close together. And you have to choose which one's the right one. All right, next question. This one, oh man, we did a lot of these in Unit 1. So let's draw a picture. Obviously, we need some art here. All right, 6 foot tall man. Here he is. So he's 6 feet tall. And then what? He's on the ground. Great. He is looking at a bird's nest on top of a tree. So here's the tree, here's the little bird, bird's nest, peep peep. And he is looking at an angle of elevation, so here's where he would normally be looking. And here's where he's looking now, at an angle of elevation of 57 degrees. So wow, my picture's not to scale. It's not surprising, but it doesn't matter. We're just trying to get the basics set up. So he's standing 25 feet from the tree. So like from here to here is 25 feet, which also means from here to here is 25 feet. And we want to know how tall is the tree. Well, right now with the triangle we have set up, we can find this height, and then we can just add 6 to it, right? So for that we're just going to do, let's see, we want opposite over adjacent, so tangent of 57 equals x over 25. Grab our calculator again. So we need to do tangent 57 times 25. And that would be the height, except then we just have to add the extra 6 feet that we had from his eyes to the ground. So plus 6. And we get 44 point, we'll call that 50 feet. Yay. Yeah, so anytime you have a problem like this where it's like looking at angle of elevation or angle of depression, if they mention like how tall someone is or how far off the ground they're standing or something like that, just don't forget to add that back in to your final answer. All right, number 11. So there was a typo on this one. I don't know if you guys talked about that, but B should be divided by 25 here. Because otherwise there's 2 answers that are not appropriate, and that's tragic. So 2017, Ms. Thompson made a mistake, made a typo. That's too bad, but we'll fix it. So converting from parametric to rectangular, what you want to do is you want to solve both for t and then set them equal to each other. So to solve this one for t, we would add 3 to both sides and then divide by 5 on both sides. So we get t equals x plus 3 divided by 5. For this one, to solve for t, we would subtract 4 from both sides. So y minus 4 equals t squared, and then take the square root of both sides. So t equals the square root of y minus 4. Then we just set those two things equal to each other. So since they're both equal to t, by the transitive property of equality, they're equal to each other. So the first version of this equation we get is x plus 3 divided by 5 equals the square root of y minus 4. And hey, look, that's exactly what option A looks like, which means it is an appropriate answer to converting this, which means it's not what we're looking for. Okay, well, the next one, it's solving for y, so let's just go ahead and solve this for y, see what it looks like. So the first thing we need to do is square both sides, and this is where the typo came from, because when you square it, you have to square the top and the bottom of a fraction. X plus 3 squared is x squared plus 6x plus 9 divided by 25 equals y minus 4, and then we would just add 4 to both sides. So you can see that that's going to look like this, which means this is not the answer we're looking for. You can also see how this one now shows you the wrong answer because it's not being divided by 25, and they added the 4 here instead of adding it on the outside to the entire fraction. So C is actually the one that is a not good answer, which means it is the answer to the question. And we can see D comes from solving for x. So if you came back here, you'd multiply both sides by 5 and then subtract 3. So since it's a good answer, it's not the one that we want. Yeah, so those are the ones that Allie asked me about. If you have any other questions, please let me know. I'm also going to send the answer keys, if you guys haven't seen this already, just to, part 1 and part 2, the multiple choice and the ones that are like free response that ask you to do more, like the sinusoidal modeling and, what was that another one? Like, what am I thinking of? Conic sections, there's something about that. I'll send that so you can take a look at it. And please let me know if you have any questions. Email me anytime. It might take me a few hours to get back to you because I work 2 other jobs, but I will make my best to make time for you. I miss you guys a lot, and I hope that you are doing really, really well. Also, if you're wondering what that sound is in the background the whole time, that is a dog chewing on a bone. And if you're wondering maybe why this video looks weird, it's because it's filmed on my phone on top of a cooling rack stacked on top of 2 boxes of tissues. So, you make do with the hand that you're dealt. But good luck on the finals, you guys, especially seniors. You can do it. You're almost done. All right, bye.